Is it mathematically possible to create a healthy diet from your favorite foods while minimizing costs? That and other stimulating questions could be answered by using the topic of today's lesson, linear programming. The goal of this lesson is to solve problems using linear programming.
What you should understand by the end of today's lesson is that some real-world problems involve multiple linear relationships. Linear programming is a method for finding a minimum or maximum value of some quantity given a set of constraints. Here is a sample problem. It says consider a linear programming problem with the following constraints and objective function p. Alright, so here are the following constraints. The constraints are nothing more than a linear inequality. This one says that y is less than or equal to negative 3x plus 9. And that's this line right here because we started at 9 and they went down at a slope of 3. The next one is y is greater than or equal to 0, or x is greater than or equal to 0, and that is a vertical line. Y is greater than or equal to 0 is a horizontal line. Now these three lines intersect at 3 points. These 3 points are the vertices, and here is our objective function. P equals 6x plus y. But they want to know, they're calling wherever it's shaded, this is called the feasible region. So anything that's feasible would lie within this region. The question that they're asking is, what are the vertices of this feasible region? So all you have to do is write down the x, y value of these points. So the first one is at the origin, which is 0, 0. The next one is when x is 0 and y is 9. And the final one is when x is 3 and y is 0. So that's all you have to do when you're finding the vertices, is look at where the lines intersect and write down those points. Here's your practice problem 1. The next example says consider a linear programming problem. It has these constraints and this objective function f of x, y, and it's equals 3x plus 7y. It wants to know the minimum value of the objective function. Well, here's our feasible region. So to find the minimum value, all you're going to do is take these 3 points and plug in the x value and the y value and solve. So for example, let's write down these points. My first point is when x is 2 and y is 6. X is 2, y is 6. So I'm going to come up to this function, make x 2 and y 6. So 3 times 2 is 6, plus 6 times 7 is 42, and 6 plus 2 is 48. So that is the value at that point. Now let's look at this point. My x value is 8. My y value is 6. So we'll write down 8, 6. When x is 8, we have 24 plus 42. we have 66 as that value. And our final point right here is when x is 10 and y is 10. So we have the point is 10, 10. So I have 30 plus 70, which equals 100. They want to know the minimum value. Well, the minimum value means the smallest number, which is 48. So the minimum value of that objective function is 48. So in other words, you're plugging in the x and y value of each point, plug it into the objective function, and find out whether they want the minimum or the maximum value. Here's your practice 2. Here's practice 3. We have 3 more constraints that have been graphed. They have been shaded in. That's our feasible region. We have our objective function, c equals 5x plus 12y. And this time they're asking, what are the values of x and y that minimize the objective function? So now we're going to find out which one is the minimum value and then just give that x and y value. So we're going to basically be doing it the same way. So I'm going to look at my points, and my first point is this one, when x is 2 and y is 7. So I have 2 and 7. So I have 10 plus 84, that's 94. My next point is 5, 4. 5 times 5 is 25. 12 times 4 is 48. I get 73. And my last point is at 10, 3. Ten times 5 is 50, plus 3 times 12 is 36, and that's 86. The x and y value that minimize the objective function, that's my smallest number, so the point that minimizes it is when x is 5 and y is 4, which is that point right there. Here's your practice 4. The last 2 practice problems you're going to do are a little different, at least in IXL. So again, we have our 3 constraints. They are inequalities. We have our objective function, which is f of xy. It equals 9x minus 12y. They want to know the minimum value, which means we're just going to plug the numbers into x and y and find out the value. This time we have 3 colored buttons, and underneath that it's going to have a shading button. So you're actually going to be shading in the area that is enclosed by the 3 lines. So you're going to have to graph these lines and find the points. So I'm going to show you how you're going to do that on a video. Here's your practice. All right, here we have three inequalities. We're going to graph the lines up here on the graph, and then we are going to use f of xy equals 9x minus 12y. We're going to use where these three lines intersect to find the minimum value of the objective function. So we're going to start with y is less than or equal to 1/2 x plus 1. So my first point I'm going to make at y equals 1. Then I'm going to use the slope, which is up 1 and over 2. So I go up 1 and over 2. So there's my first line. Going up 1 and over 2, it's a positive slope. My second line is negative x plus 10, so I start at plus 10, and I'm going down 1 and over 1. It's negative 1 slope. The third line starts when y is 4. It is also a negative slope. I'm going down 1 and over 4. Now I'm going to shade the part, and as you can see, this is the part where the three intersect, and I have 3 points of intersection. I have this point, and that point. So I'm going to plug those x and y values in here to find the minimum value of the objective function. So my first point of intersection is when x is 4 and y is 3. So on my calculator, I'm going to use when x is 4, I have 36 minus 12 times 3 is 36. So I have 0. That's a number. Now I'm going to go when x is 6 and y is 4. 9 times 6 is 54 minus 12 times 4 is 48. That's 6. And my last one is when x is 8 and y is 2. So I have 72 minus 12 times 2 is 24, and that's 48. So my first one was when x is 4 and y was 3, and that minimum value was 0. Practice 5. You're going to be doing the same thing. And practice 6. Remember, on these two, you can draw your lines by finding the x and y intercepts by making x 0 and solving for y, making y 0 and solving for x. The cross-country team is selling water bottles to raise money for the team. The price of water bottles is $3 for students and $5 for everyone else. The team needs to raise at least $400 and has 100 water bottles. Write and graph a system of inequalities that can be used to determine when the team will meet its goal. That's the kind of questions we'll be able to answer in the next lesson. Thanks and have a great day.